Here we're going to look at the matrix multiplication for this row matrix multiplied by this column matrix. So the dimensions of this row matrix are 1 row by 3 columns, and the dimensions of this column matrix are 3 rows by the single column. We notice the values in the middle are the same. The first matrix has 3 columns and the second matrix has 3 rows, so they're good to go. So we can do this matrix multiplication. So we know the dimensions of my product matrix are going to be 1 by 1, 1 row by 1 column. So I'm only going to have a single entry when I do this. Well, how is it that I get this entry? So I'm going to be working across the row matrix and down the column matrix, and in this product matrix here I have the entry at row 1, column 1, so I'm going to use row 1 and column 1. It just happens that this row matrix only has the single row and this column matrix only has the single column. So what happens is I'm going to go through and do consecutive terms, and I'm going to multiply, so 2 times 4, I'll write that down, and I'm going to be adding consecutive terms, -5 times -1, and then 7 times 6. So each corresponding fella here gets multiplied, and then all the consecutive products get added together. What that looks like now is 2 times 4 is 8, and then plus 5, and plus 42. When I add all that up, I'll have 55. So I have a 1 by 1 matrix whose only entry is 55, and that came from multiplying this row matrix by this column matrix.